Hello everyone. Today we'll be discussing Secure Shell, otherwise known as SSH, and OpenSSH, and how it relates to Linux systems, and also we'll discuss how to configure OpenSSH with a Linux server. We'll also be discussing a few hardening recommendations for OpenSSH on a Linux server. So let's get into it. So let's talk about Secure Shell. So SSH, or Secure Shell, is a network protocol that is predominantly used for securing information or communications between systems across unsecured networks or the public internet. So it provides security between two computers through strong password authentication, along with using encryption, which we will discuss soon, to secure data that's being transferred, which basically protects it from either eavesdropping or someone intercepting that traffic. SSH also allows for system administrators to connect to their server remotely, as if they were on the server itself, and they can perform a variety of tasks as if they were on the server, such as moving files or configuring applications. So the SSH model is a client-server model where the client has an application attempts to establish a connection to the SSH server. The SSH server then sends a response whether the connection was allowed or denied, and if the connection is established, they are able to run that application inside the SSH server and do so securely. And SSH was actually designed to replace Telnet, as the former had become a common exploit for attackers. The reason for this was the data that Telnet transmitted was unsecured and unencrypted, so hackers could basically intercept the traffic, edit it or alter it in any way they see fit, and then send it back on the route that it was taking, and that could cause all sorts of issues. This is also known as a man-in-the-middle attack, or they could just eavesdrop on the data and intercept it, and then send it back on its way. So Secure Shell remedied this by encrypting the data so that it could not be as easily altered or viewed. So now let's actually talk about how Secure Shell functions. SSH runs on the TCP IP suite, or Transmission Control Protocol IP protocol, or Internet Protocol rather, suite. Whenever data is transferred using SSH, the data is encrypted using public key cryptography, in which there are two sets of keys where there is a public key and a private key, and the public key is available to everyone, and the private key is available to only its owner. And these keys are used for encryption and the authentication of the device that's connecting to the SSH server and the SSH server, so they can basically authenticate each other. So SSH also allows for tunneling, which can also be defined as port forwarding. This is a process where data is able to be transmitted over a network that it would not typically be able to. So for example, if you were trying to remotely connect to your system that was typically a private network, you would be able to do so remotely, as if you were on the network itself, which is why the network doesn't recognize you as a foreign entity. It recognizes you as if you were on the network. So it accomplishes this by creating a secure connection or a tunnel between your system and a server you wish to connect to remotely. Once the connection is established, the user or the network administrator is able to transfer encrypted data or make changes to the system, even on what would usually be a private network. that would deny remote connections inherently. All right. So now that we've discussed what Secure Shell is, let's discuss OpenSSH and how to configure an OpenSSH server through Linux. So OpenSSH is an open source software that utilizes the Secure Shell protocol. It's basically a network utility tool or a collection of tools that allow for more secure communication across an unsecured network and communication between two devices or systems. So now let's discuss how to actually implement an OpenSSH server on a Linux system. The first step is to install the OpenSSH server package through the Linux terminal, and that is done using the following command: sudo apt install OpenSSH-server. And once that's finished downloading, you are provided the option to configure the configuration file, which is found under /etc/ssh/sshd_config. And there you are basically able to do a variety of things, such as create server backups, create a login banner that provides issue information to its users, and along with other useful information. Then start the SSH server and generate a public key pair using the following command: ssh-keygen-t RSA. You're also able to create keys of different sizes, bytes, by adding the desired size to the end of the aforementioned command. And so lastly, you should create users for the server, and you can do this using two-factor authentication through U2F or FIDO, which are OpenSSH supported with the latest version. Then lastly, you restart your server and log in using the multi-factor authentication that was just created using those two tools. So now that we've discussed Secure Shell as well as the OpenSSH software, let's discuss some hardening recommendations to secure your OpenSSH Linux server. The first recommendation is to limit authentication attempts. Limiting the amount of login attempts for a user can provide protection against a variety of attacks, but also brute force attacks would probably be the most predominant that this would protect against. This also will reduce the strain on your server, as resources don't need to be allocated to numerous login attempts. Next would be to configure, allow, and deny users. Using one of these two methods, basically creating a group of users that are able to either access your server or configure it, depending on what you see fit, or you could create the deny users, which denies specific groups of people from accessing your server. Doing this ensures that only the ones that you want authorized to your server are able to do so. And lastly, we have use known_hosts. So typically whenever your connection is established to the SSH server, a signature is created. And that signature basically tells the user you've connected to this server before and this is the correct server. It's a hash value, and it basically assures you that this is the correct server that you need to be connecting to, and it will notify the user if the signature for the server ever changes, and that protects the user from potentially connecting to an unwanted server that they do not recognize. And lastly, we just have a few references that we used for this presentation. That'll be all for today. Thank you so much.